This video is for section 4-9, Dividing Polynomials. You use the distributive property to divide a polynomial by a monomial. The result can be a sum of fractions, a polynomial, or a sum of a polynomial and fractions. Here are some examples. They're a little bit blurry in the video. Hopefully they show up on your note page. Here is a polynomial, and it's being divided by the monomial 3t to the fourth power. Apply the distributive property. Divide each term in the numerator by the denominator, and that's shown right here. Then simplify each of those results, getting this answer. You can see that this answer is a sum of three fractions. Now here's another example. There is a trinomial divided by the monomial u. Apply the distributive property. Take each of the terms and divide by u, which is written right here. And then simplify each of these fractions. U over u makes 1. 2u squared over u, when you use the rule about subtracting exponents, 2 take away 1, makes this result. U to the fifth divided by u, when you subtract exponents, makes u to the fourth. So the answer is a polynomial. The third example shows a polynomial with 4 terms being divided by a monomial. Apply the distributive property. Divide every term by 6x squared and simplify. You'll notice the answer has a polynomial plus some fractions. Perhaps you remember doing these kind of divisions in Algebra 1 class. But what about dividing a polynomial by a binomial? To do this, we can't really use the distributive property. Instead, we're going to use the long division algorithm. So first, here's a reminder of how long division works, just using regular numbers. If you wanted to divide 313 by 21, you could figure out how many 21s are in 31. And there's 1, which you write down up here. Because of place value, you aren't really figuring out there's 1 21 in 31. You're figuring out that there are 10 21s in 310. 10 times 21 is 210, which you write underneath the 313. Then you subtract the numbers to get the remainder of 103. How many 21s are in 103? And there's 4 of them, which you write up here in the ones position. 4 21s is 84, which you subtract from 103 to get 19, called a remainder. Therefore, 313 divided by 21 is equal to 14 plus 19 out of 21. We can use this same algorithm where you figure out a number up top, multiply it to the number out front, and subtract to get a remainder to do polynomial division. Let's try an example. Divide z squared minus z plus 5 by z plus 1. The first thing to do is to write this in a long division bracket. We want to divide z plus 1 into z squared minus z plus 5. Z times what makes z squared? Well, that's z times z. Then multiply what you wrote up here by the number out front and write it down underneath your polynomial. Z times z is z squared. Z times 1 is positive z. Now subtract. Z squared subtract z squared is nothing. Negative 1z subtract positive 1z is negative 2z. With regular long division, do you remember what you do with the next digit? You bring it down. That's what we're going to do here. Bring down the positive 5. Now figure out the next number up above. Z times what makes negative 2z? And that would be negative 2. Negative 2 times z is negative 2z. Negative 2 times 1 is negative 2. Now subtract. Negative 2z subtract negative 2z makes nothing. 5 subtract negative 2 is 7. My past experiences with Algebra 2 class lead me to caution you when you're doing these subtractions. Remember that you are subtracting. You're not simply combining these together. It's not 5 and negative 2 makes 3. It's 5 subtract negative 2, which is 7. Similarly, that subtraction right there. It's not negative z combined with positive z makes 0. It's negative z subtract a z, which is negative 2z. The result, 7, is called a remainder. And to write the answer, you put the remainder on the end of the quotient. Z minus 2 plus 7 out of z plus 1. When dividing polynomials, the terms must be written in order of descending degree, and terms may not skip degrees. You may have to insert a term with 0 as the coefficient as a placeholder. Continue the division process until the degree of the remainder is less than the degree of the divisor. In the example we just did, our remainder 7 has no variable, so it's degree 0, which is less than the divisor, which was z to the first power. That's how I knew that that was the remainder, and I was done. Let's try another example. 9 minus v cubed divided by 3 plus v. Remember what we just discussed. You have to write the polynomials in order of descending degree. So the negative v cubed first, then the v squared term. There isn't one, so you need a placeholder. Then the v term, then the constant. The same for your divisor. The v term first, then the constant. Now we can use long division. V plus 3 is being divided into the negative v cubed plus 0v squared minus v plus 9. When you're figuring out the numbers up here in the answer, focus on leading terms only. The v and the negative v cubed. V times what makes negative v cubed? It's negative v squared. Then multiply that to the divisor out here and write down the answer underneath. Negative v squared times v is negative v cubed. Negative v squared times 3 is negative 3v squared. You can check that you're getting the correct answer up above because the term you get here must be identical to the one right above. If they are not exactly the same, you did not find the correct value here. Now subtract. These terms cancel away. 0v squared subtract negative 3v squared is 3v squared. What do you do next? You bring down the next term. Now figure out the next number up above. Focus on leading terms only. Focus on the v and the 3v squared. V times what makes 3v squared? Positive 3v. 3v times v is 3v squared. 3v times 3 is positive 9v. Now what do? Subtract. Negative 1v subtract 9v is negative 10v. What do you do next? Bring down the next term. Now you're going to figure out the next number up above. What would it be? It's negative 10. Here's why. Negative 10 times v is negative 10v, the number that we're trying to create. Negative 10 times 3 is negative 30. Now subtract. 9 subtract negative 30 is 39. Again, I want to caution you to be so careful with the subtraction step. 9 subtract negative 30 is the same thing as 9 plus positive 30, which is 39. The 39 is the remainder. which gets attached onto the end of the quotient up above. So over here on the side, let's write our answer. Negative v squared plus 3v minus 10 plus 39 out of v plus 3. Let's summarize the lesson. We reviewed how to divide polynomials. We started with dividing monomials, which are done using the distributive property. Here are 3 examples of that. Then we divided by a binomial, which is done using long division. And we looked at 2 examples of that. In our second example, our polynomials were not written in the correct order, and the v squared term was missing. So when we wrote our long division, we needed to change the order and fill in a 0 v squared as a placeholder.